Hi everyone, today we're going to be talking about half-life and how to actually calculate the amount of material left after a certain number of half-lives, or how long your half-life is based on the amount of material. We will have several equations we'll be learning today, but let's just remember that the half-life is the amount of time that it takes for an element to decay down to half of the amount it had in the beginning. So, like we talked before, this is a exponential decay where when you have, say, 100 grams to start with, after one half-life you have 50 grams. Then, after another half-life, you would only have 25 grams instead of all of it going away. And it just becomes a smaller and smaller number, but never really goes to zero remaining material. And so the definition is just here again for you in case you need to remember it. But let's actually look at how to calculate half-life. So we have an equation down below where it says xf equals x0 times 0.5 raised to the n power. But before we can get to that, we need to talk about half-life and time and how we can define this. The first equation up here in the top left, n equals little t over big T. Little t tells you how much time has gone by. We can also call that time elapsed. Okay? So say I waited around for 5 years and then measured how much stuff is left. My time elapsed would be 5 years. My material has a half-life that is a constant amount for that material. So say I'm using plutonium and say it has a half-life of 49 years. Okay? So that means it takes 49 years for plutonium to decay by half. And so if I wanted to know how much plutonium, how many half-lives went by, I could plug those into this n equals t over t. So let me write that out. So I just said, for example, my time elapsed is 5 years because I waited around for 5 years to measure the amount of remaining sample. And for my material, let's say that its half-life, big T, is 49 years. If I wanted to know how many half-lives lives, question mark, have passed I could use this n equals little t over big T equation. Because n, how many half-lives? That is n. Okay? So I'll plug that in. I would have 5 years over 49 years, which years cancels, and that would give us our n, but I'll write it over here what the answer is to the left. I need a calculator. Should be pretty close to 0.1. So 5 divided by 49 gives me, okay, like I said, 0.102 half-lives. Okay. We could round that to one significant figure and that becomes 0.1. Okay? Alright, so that's how many half-lives. That's our n. Alright, so if we started out with, say, our initial amount of material, let's say our initial amount of material is 100 grams. And we want to know how much material is left after these 5 years. So after we've passed 0.1 half-lives, since our half-life is such a long amount of time. So xf is the one thing I'm looking for, therefore that means it's my unknown, and I can just leave that in the equation. So this is the big half-life equation, so eventually you're probably wanting to use this if you're doing a half-life problem. So my unknown xf equals my initial amount, which was 100 grams, and that's times 0.5 raised to n, which we already calculated is 0.1 half-lives. Alright, so what's really, really important here is that when you use your calculator for this problem, you want to make sure you take this 0.5 and raise it to the power before you multiply by 100. Otherwise, you're going to get a different number. So 0.5, and then there's a little, on your calculator, you'll probably see a button that looks like that. That means to raise to a power. So I'm going to raise it to the 0.1 power. And that right there gives me 0.933. Okay, so I'm going to plug that back in. XF equals 100 grams times 0.933. So that's where I've literally just taken the 0.5 and raised it to the 0.1 power, and that gave me 0.933. So now if I take that times 100, my final amount will give me 93.3 grams. So let's think about whether that number makes sense. We know that this stuff is decaying, so my final amount should be less than my initial amount, and 93.3 is indeed less than 100 grams. Should it be down to half or farther than half? Well, in order for it to be down to half, we would have had to go a whole half-life by. Did we wait for 49 years? No, we only waited for 5 years, so we should expect only a small amount of our material to go away compared to an entire half. So about 7 grams have decayed, and that makes sense based on how long our half-life is and how short of a time we waited. Okay, so let's try another problem. So the half-life of this element, it goes ahead and tells us that it's 2.4 minutes. If one had 100 grams at the beginning, how many grams would be left after 7.2 minutes has elapsed? So that means first we need to figure out how many half-lives have gone by. So we can use the n equals little t over big T. We know our little t is the amount of time that has gone by, or the amount of time elapsed. So when you read the equation, the first thing you need to do is read each number and unit and figure out what that's talking about. So this one, 7.2 minutes has elapsed. That means 7.2 minutes has gone by, therefore that means this is our little t. Okay? Now the other time in the equation is 2.4 minutes. And it tells us that that's the half-life. So this must be our big T. Alright. And then finally, we can use those two numbers to calculate our number of half-lives. So I'll take 7.2 minutes, divide by 2.4 minutes, and that'll give me my number of half-lives. Important side note. If your units of time are not the same, you need to convert them so that they are the same, because your number of half-lives should just be a number. It should not have a unit. So here when I divide these two, I get 3 half-lives. Alright. So I can take that's my n, right? And I can plug that into my big half-life equation, because I already know how much stuff I started with, right? It tells me that in the question. This is my x0, and what is my unknown? My unknown is how many grams are left at the end. So this is my xf, so my xf is my unknown. Alright, so that means I'm going to go ahead and plug in. xf equals 100 grams. It says 100.0, so that's a lot of significant figures. That's kind of important. Okay, 100.0 grams times 0.5 raised to the third power, because we've gone 3 half-lives. Alright, so I'm going to take 0.5 and I'm going to raise it to the third power, and that gives me 0.125. So I have 100.0 grams times 0.125 equals xf. Alright, finally I can multiply by 100 and see what I get. I get 12.5, and I want to keep this as 4 significant figures from my mass that I started with. So 12.5, that's only 3 significant figures. So I can add on a 0 at the end to be my 4th significant figure. You're allowed to do that. So that's my final amount of material. Let's just make sure this makes sense. If I started out with 100 grams and I've gone by 3 half-lives, after the first half-life, I should have how much left? Well, 100 grams, half of that would bring me down to 50 grams. After the second half-life, how much should I have left? Now I should have half of 50, which is 25 grams. And then after the third half-life, I should have how much left? Half of 25, which is 12.5. So we have calculated this correctly, and we have arrived at the correct answer. All right. There might be some cases in which you do not know how many half-lives have gone by because you don't know the value of one of your times. And in this case, we have to use the equation that's up in the top right box. Log xf minus log x0 over log 0.5 equals n. Okay? Now, for any of these values, all you have to do is write it all out with your correct numbers, and you just push the log button on your calculator and then type in the number and then subtract log button, next number. Then divide that whole thing by log button 0.5. It's very simple. It looks intimidating, but it's not hard, because if you can push a button, you'll be fine. So I just wanted to show you really quickly how we got this equation. And this is using log rules, so if you don't know your log rules, you might get a little lost, and you can just ignore this part and just know that the equation in the box is what you're going to use when you don't know n. So, to start out, if we want to get n by itself, the only way you can do that when it's an exponent is to take the log of the entire equation. So that means I'll take log xf, I'll take log x0, 0.5 n. Alright, so using log rules, when two things are multiplied, which this is multiplied by this, when you take the log of them, you can separate it into two separate terms that are added together. So log x0 plus log 0.5. And we still have this n here. Alright, so that's the first log rule that we're using. The log rule for multiplying. Alright, now the second log rule we're going to use is getting this n out of the exponent. And basically when you take the log of something that's raised to a power, that power can come out front. So this will become log xf equals log x0 plus n times log 0.5. Alright, so remember we want to get n by itself. So I'm going to erase this stuff. And we'll move back up because I'm running out of space. Alright. So I know that I can go ahead and move this term to the other side because we want n by itself. So I'll do that by subtracting because right now it's being added on the right side. So log xf minus log x0. Does that look familiar? Yep, that looks just like what I have up here in the equation in the box. Okay, and that'll be equal to n times log 0.5. Now you might guess my last step here. If n is multiplied by log of 0.5 and we want those two things to be away from each other, the opposite of multiplying, dividing. You got it. So let's divide by log 0.5 on both sides, which cancels it out on the right side. And that gives us our equation that we were looking for. So You're going to use this, and I'll give you examples in a minute.